The description of the asset blockchain platform in the context of Work Package 3, Task 3.2 for cybersecurity for Europe. We think that this asset could be integrated into the Smart Campus demonstrator in the context of Work Package 3 to serve as its distributed ledger technology backbone. The combination of satellite chain, smart contracts, all features of our platform that we will discuss in shortly, can take care of the heterogeneous services available to the users in the Smart Campus scenario. For example, different services can have different dedicated satellite chains which are accessible only to those users that can access them. And complex authorizations operation, such as registration and ID verification, can also be carried out by smart contracts. This asset provides a blockchain as a service platform with improvements over the state-of-the-art solution that address a number of important issues that make this technology suitable for the fintech world. In particular, in the context of privacy, existing blockchain platforms work by broadcasting transactions to the entire network. However, both the corporate world and private citizens value their privacy, and they want to restrict data sharing to a number of parties of their choice. Exchanging encrypted transactions is a good practice, but it's still not enough to solve the problem, because encrypted transactions still let the network know when a particular transaction occurred and between which parties. In the context of scalability, permissionless blockchains such as Bitcoin and Ethereum have an excellent scalability, but sacrifice throughput, whereas permissionless blockchains can achieve higher throughput but sacrifice scalability. However, today's standards require a scalable blockchain architecture that does not sacrifice throughput. And finally, lack of governance. Blockchain became popular because they offer a distributed platform that does not need a trusted third party. However, in real deployments, organizations and service providers want to be in charge of their networks in order to enforce business logics and policies of their choice, and also to be able to grant or deny access to their services as they see fit. The key feature of the platform is its architecture, which comprises a novel concept called satellite chains, of which you can see a picture here. Satellite chains are small independent blockchains with their own ledger, with their own applications and consensus algorithm and participants. Even though they are independent, this architecture does not prevent the transfer of assets from one satellite chain to another, because all satellite chains are part of a larger parent network, usually managed by the network's owner. And this parent network keeps track of the active satellite chains, but does not interfere with their normal operations. The advantage is that information is exchanged only between intended parties, thus limiting the sharing of knowledge to who really matters. The only requirement is instantiating a satellite chain that all the participants that want to exchange transactions can join. Transactions exchanged within that particular satellite chain are visible only to its members. So in this example here, the circle's satellite chain does not know that the triangle satellite chain exists because they are independent. And similarly, the square satellite chain and the circle satellite chains are not aware of each other, even if one entity is a member of both satellite chains. Only that member knows the existence of both. And there, of course, can be as many satellite chains as the use case needs, and so there is no upper bound to them. And this gives us two benefits: efficiency, because participants do not have to store transactions that are not relevant to them, and scalability, because by allowing an unbounded number of satellite chains to work in parallel, the platform achieves a higher throughput than existing deployments. Of course, smart contracts are available as well, meaning that organizations can implement their business logics and policies via code uploaded to the blockchain. In particular, the organization managing the network can also assume the role of a regulator that implements policies that can apply to all satellite chains active in the network. The core of the platform is its consensus protocol, which we call FastBFT, which is a Byzantine fault-tolerant consensus protocol. Existing Byzantine protocols performance usually decreases as the number of nodes increases, and the message exchange is usually quadratic. However, FastBFT uses a message aggregation technique that leverages hardware-based trusted execution environments such as InterestGX that allow it to lower its message complexity from ODN squared to linear, ODN. And our experiments show that as the number of nodes increases, our protocol's throughput in terms of transaction processes per second decreases slower than other state-of-the-art protocols, and in some scenarios can reach over 100,000 transactions per second. Here you can see the performance graphs that would be measured. In the first graph on the left, you see the throughputs again in terms of operation per second and against the latency. And as you can see, FastBFT can perform way more operations per second than other state-of-the-art Byzantine protocol. And on the right, you see that our FastBFT protocol can tolerate a higher number of faulty replicas without slowing its performance. The blue line there can reach 200 nodes without significantly increasing its latency. And finally here, what you see is that our protocol has a steadier performance when compared to other known protocols. And in particular, again, here we can see that the size of the network has a significantly lower impact on the protocol's latency and throughput than its competitors.